You ever wonder if we could actually see a disaster coming? I mean, not just a few hours ahead, but days, maybe even weeks in advance. It's an incredible thought. But when you're talking about the raw power of tectonic hazards, earthquakes, volcanoes, tsunamis, what can science really do? Today, we're going to dig into that very question. Is precise disaster prediction something we can actually count on, or is it still just science fiction?
So, picture this. You wake up, you check your phone, and bam! There's a headline flashing on your screen. Massive earthquake to strike tomorrow at 2:15 p.m. It's the kind of super specific, terrifying alert you see in the movies, right? But could a real scientist ever make that call? The answer to that question gets right to the heart of a huge misconception about what we can and can't do.
Okay, so this gets to the single most important idea we're going to talk about today. The difference between prediction and forecasting. Prediction, that's the movie scenario, pinpointing the exact time, place, and size. Forecasting, on the other hand, is all about probability. Think of it more like a weather report, but for the Earth's crust. It's about estimating the likelihood of something happening in a general area over a period of time. One's a guarantee, the other is about playing the odds. And that one little difference, well, it changes everything.
All right, let's dive in with the big one, right? The hazard that really captures our imagination and our fears the most: earthquakes. When it comes to knowing exactly when they'll hit, well, let's just say you shouldn't set your clock by them. Let's just get this out of the way right up front. Predicting the exact time, place, and magnitude of a future earthquake is, right now, not scientifically possible. We're fantastic at identifying high-risk zones. You've heard of the Ring of Fire, for example. But telling you the exact moment the ground is going to start to shake? Nope, we're not there.
So why? Why is it so darn hard? Well, for one, all the action is happening miles and miles beneath our feet. You have these massive cracks in the Earth's crust called faults, and stress is just constantly building up along them. But when that stress finally lets go, it happens suddenly and in a pretty chaotic way. The real problem is that there just aren't any clear, consistent warning signs or precursors that tell us a fault is about to snap.
Here's a good way to think about it. We can see the pressure building. We can monitor it for years, even decades, but we can't know the exact breaking point. It's like we can measure the tension in a rubber band as it stretches, but we have no idea when it's going to pop.
Now, this doesn't mean scientists are just, guessing in the dark. They have an incredible toolbox. Seismometers are like the planet's heartbeat monitor, picking up the faintest tremors. Super precise GPS tech can literally measure the ground stretching and squeezing by millimeters, showing us where that strain is accumulating. And yeah, researchers are always looking at other potential clues, like changes in gas emissions or groundwater. But so far, nothing has proven to be that reliable countdown clock. These tools are absolutely crucial for mapping risk, but they just can't give us the when.
Okay, so let's switch gears. We'll move from the silent, sudden threat of earthquakes to the loud, rumbling warnings of volcanoes. And here, the story is completely different. Because unlike earthquakes, volcanoes, well, they tend to talk to us. They give us signs. And really, the difference couldn't be more dramatic. Where earthquakes are just frustratingly silent, volcanoes usually announce their intentions pretty clearly. They give us clear, measurable signs before they erupt. And that is the fundamental reason our forecasting is so much better for them. So what are we talking about here? What are these telltale signs? Well, as molten rock, magma, pushes its way up from deep inside the Earth, it actually triggers swarms of tiny little earthquakes. And as it starts to pool in chambers closer to the surface, it can literally make the ground swell up and bulge. On top of that, as it gets closer, it starts to vent gases like sulfur dioxide. Every single one of these things is a clue that scientists can measure, a sign that the volcano is waking up.
And that right there, that's the real power of forecasting in action. By keeping an eye on all these signs, scientists can often issue warnings days or even weeks in advance. Now, they might not know the exact minute of the eruption, but they can create this crucial window of opportunity, allowing for life-saving evacuations and seriously reducing the risk.
All right, on to our third and final hazard: tsunamis. With these, the challenge isn't really about predicting the thing that starts it all. It's about what happens next. It is an absolute race against time. Okay, the system we have for tsunamis is honestly a marvel of engineering. It all kicks off with detection. Seismometers instantly register a powerful earthquake under the ocean. Step 2, specialized buoys out in the ocean measure any changes in water pressure, which confirms whether a tsunami wave has actually been created. All of that data gets beamed in real time to monitoring centers, which then blast out warnings to coastal areas.
And this is the key thing to get, right? The system isn't predicting the earthquake itself.
It's detecting the wave after it's already been created. From that very moment, the clock is ticking. This technology buys coastal communities precious time. Sometimes it's just minutes, other times it can be hours to get to higher ground. When it comes to tsunamis, speed is absolutely everything.
But you know, having all this amazing science, that's only half the story. A perfect forecast doesn't mean a thing if the warning system isn't there to begin with. And unfortunately, access to this kind of life-saving technology is not spread evenly around the world.
And this is the tough part, the stark reality of the situation. To put it bluntly, wealth can buy safety. Developed nations can afford to build and maintain these huge, complex sensor networks and monitoring systems. But many developing nations just don't have the resources, and that creates this dangerous warning gap, leaving huge populations incredibly vulnerable. Which brings us to a really crucial point, captured in this quote. Even the most accurate forecast is of little use if people do not respond appropriately. I mean, think about it. A forecast is just data. It's totally useless if the warning never reaches people, or if it does, but they don't know what to do next. The technology is just a tool. It's the communication, the education, the evacuation plans, that's what truly saves lives. Okay, so let's do a quick recap, a final scorecard, if you will. For earthquakes, forecastability is low. Why? Because there are no reliable warning signs. For volcanoes, it's high, all thanks to those clear, measurable signs they give us. And for tsunamis, forecastability is also high. But, and this is a big but, it's based on detecting the wave after the initial event has already happened.
So look, a perfect crystal ball prediction might still be science fiction for now. But science has given us the next best thing, the power to forecast risk. And really, that puts the ultimate responsibility back on us. The technology can give us the warning, but our survival, that depends entirely on our preparation. The science is there. The real question is, are we ready?